Hello everyone, now we are starting the part 3 of our sequence of videos about HVAC systems in COVID-19 times. And in the previous videos we discussed the basic concept of contamination control, what are our issues right now. We discussed filtration and containment using VAV boxes and how installation rooms work at hospitals. In this part we will discuss the following concepts and the techniques that we can use for the general buildings, general use buildings, and a little bit more about the hospitals. So from the contamination control, we thought that we had like 4 tools, engineering tools available to help reducing the spread of airborne diseases. It would be containment, capture through filters, dilution, like moving the air and fresh air, and the control. And we will discuss a little bit how we can control right now. Today is the July 15th, and the other 2 videos are also available, and please watch all of them. So if we think about our buildings and control, what we mean with control is to work the conditions in our building in just a way that we can reduce the risk of contamination or of infection or infections. And Ashai, during many years, presented this graphic, like showing from 30 to 60% range of the humidity inside of the room as the best range to avoid the risk of for the health of the occupants. So it's not that in this area we don't have these microorganisms, it's that in this area our body is able to act against them. And that's the range of humidity that's proven that we have the better results from our immunological system against all these diseases, and it will protect the building and protect people inside of it. And more recently, Dr. Stephanie Taylor began to talk and explain that it's better to work between 40 and 60%, and that's the range where we can reduce a lot of like hospital infections in hospitals. And so she did some studies mapping the conditions in the hospital and making the analysis of the data, and came out that this range we have a reduction of the potential of infections. And also quite really important, we saw that in the previous videos, is that when we have low humidity, first we will have more desiccation of the droplets and generate more of the nuclei that will stay in the air and can go back into the air. Also, if we have low humidity, if it goes below 20%, it's really bad for us. So it begins to dehydrate our body. We will feel, we will have bad sensations, but also it will dry out our noses and so on. It will reduce our natural defense, our natural filters. So we need to keep the humidity above 20%, and ideally between 40 and 60%. It's also important in several buildings around the world, they don't use humidity control like with humidifiers, humidification with devices to do it. We need to be really aware from how our outside air is, because we are going to inject it into the building, and we need to make a really good psychometric study of how to treat the air and bring it into the unit, into the building, and treat it in the air conditioning units. So sometimes we need to use custom-made air handling units. So that's basically what we can do with control. We will create the space, temperature, and humidity in such a way that inside the building we can restrict the spread of diseases. So, and how can TROX help with that? With custom-made air handling units, we have factories in Germany, Spain, Brazil, Argentina, and Mexico, Morocco, and Egypt, building air handling units, custom-made air handling units. So we have a wide range of and also China. So we can supply worldwide the solution for air handling units with heat recovery, filtration, all steps of filtration, humidity control, humidification, and onboard control. So we can do it specifically for the needs from each project. Going now into the room from our patient and looking into what happens inside, and here we are reviewing some concepts from the first video. It's like we have a source of droplets, and that's our patient, our infected patient. And these droplets will, some will be floating around in the nuclei, the smaller ones, the aerosols. Some will come to the ground. and then they will begin to desiccate, so they will lose the humidity. And when we change the clothes of this bed and move stuff around in this room, we'll make this nuclei go up in the air again. So that's one of the reasons that World Health Organization recommends when we are doing that at our home, and there is a sick patient, that we open the windows so that we can get fresh air into the room. But in a hospital, we don't have this option, so we need to work out with the air. So going back to the rooms for airborne infections, and again, that's the CDC recommendation. The room has to work with negative pressure, and the air has to come from the clean part to the dirty part. And that means that if the medical staff is here, here's our patient, we will have the extraction close to the patient. So we don't want the air moving around, this contaminated air from the patient moving around in the room. And also, as we are working with a negative pressure, that means the supply air is less than the extract air. We will have air coming through the gap from the door. So there's no risk that these particles, biotic particles, are going out of the room. The flow will have the effect of the dilution of the contaminants. So we have air renovation, we will bring fresh air into the room to dilute it, and also we will be extracting close to the patient. Here's the guidance from the CDC, the last guidance that's valid for the hospital projects in the US, and is a reference for most of the countries when they are doing design of hospitals. So the extract air will be treated with HEPA filters. Here's more or less the same, but now with a pre-chamber, so that would be a high-level hospital where we have infected contagious, we have an antechamber, and it can have different concepts. One can be a neutral zone, or it will be also negative to the corridor, so we create a cascade of pressure control. But what happens right now is that we have too many patients in our hospitals, and we are running out of the appropriate rooms for them. So we need to adapt our normal conventional rooms for patients that are not infected contagious or immunodepressive, so they have a normal air conditioning system, and we need to add some devices to get through this crisis. So one solution is to add a unit with a HEPA filter and an air purifier. It would be a heavy-duty air purifier, and put the air back into the return. It needs to be risk evaluated with all the staff and the specialists in the hospital, like the immunologists, doctors, and so on. The other option is to seal the return and make it a full extraction system, and then we are using it with a HEPA filter and extracting it through a hole in the wall or through a gap in the windows. We get a tube through that. But in this case, what will happen is that we will have 100% supply of fresh air, because our air handling unit is not getting return anymore. So it needs to be evaluated against the drawings and the operation of the building. And that's been done in some hospitals around the country and around the world. So points to consider is that we need to keep the balance of the room. We want to keep it negative. That means the air coming into the room. If we do not have return to the air handling unit, we need to look if the air handling unit is able to treat and cool down the air to temperature they desired. We need to put this extractor close to the patient. It's not, it doesn't help if we have it close to the door. We need to have it close to the patient. It gets all the air that he's breathing, all the contaminated air with the aerosols close to the patient to these units. So we've manufactured some of these units in our factory in Brazil, and we are going to extend the manufacturing to Argentina for these purifiers. And also we are evaluating to do them in Europe. And then we have the biggest problem in countries under development. So there are some countries where they really simplify it too much, and they have to improvise the budget costing. And they use split and fan coil units that are usually for comfort in patient rooms. So they have no air renovation. There's no fresh air coming inside the room. There is no renovation. There's no outside air. And in this case, what we will have to do is that we have to open frequently the windows. That's also recommended for patients with mild symptoms. And this recommendation in all healthcare agencies are giving the same recommendation. We need to open these windows and bring some fresh air into these rooms. We need to add some, second option, we need to invest some money and add some ventilation systems, bringing fresh air into the room, and the extract fan extracting it, and then we need to filter it, and we can go back to these units that we showed in the previous slide. There is a third option that would be using HEPA filters, purified devices with HEPA filters, but definitely not the small units that we see being sold in supermarkets and some stores. That there are units designed to do that, and not units. You need to be real aware what the unit is able to do. Points to consider is we need to put equipment close to the patient. We need to see how much it can handle in air movements. If we want to keep the room negative, we need to put it in a way that we can put it out of the room, discharge it through the window or to a hole in the wall. And what will be the impact in the closer rooms? Because if we keep making this room now negative, we will be pushing air to the corridor, and this air needs to come from somewhere. So we can adapt in these cases these units we do in Brazil, but definitively that is the worst case scenario is a room that has no air renovation. And unfortunately it happens, and I can show you a picture. There's a split air conditioning system in an intensive care in a hospital somewhere in the world. I don't need to tell where it is, but it's somewhere in the world. And even if we keep all these parameters and these individual protection devices for the staff, we are maintaining this contaminated air all the time in this room. So we are recirculating. Even worse, here's a bed, and the patient is expelling all this contaminated air with the droplets, with the aerosol, and it falls into the fan of this unit, and this disperse it all in the room. So that's something that should not be accepted anymore. And that goes against all good practice of design of hospitals and engineering of healthcare systems. So now do these really bad installations that are all over the world. It's not just one country. We can find it almost in every continent. The healthcare staff is facing problems. These devices are not designed for hospitals. They should not be used in hospitals. They're designed for comfort at home. And what I recommend is that we always use, everyone that's dealing with hospitals, to read this manual from ASHRAE, the design guideline for manual for hospitals and clinics. It's now in the second edition. Is a really good book, and it gives us a good guidance. And in the document about infection by aerosols, ASHRAE also recommends that we need to be able in our hospital system to work under a contingency modus. And that means that we need to be able to capture the aerosols with HEPA filters. We need to have mechanical extraction in all bathrooms. We need to be able to keep temperature and humidity in these rooms where these patients are. Remember, from 40 to 60%, we reduce the risk of contamination, and we make our body work better. We need to be able to increase the renovation of air from 2 air changes per hour to 6 in extreme cases. We need to supply the clean air close to the patient. And when you look to that, the doctor is coming into this room and he's getting this airflow with a lot of contaminated material. These rooms with the infected contagious patients need to be kept at negative pressure. So we need to think on our hospital design. What would we do in the worst case scenario, like in a pandemic? So that will be the guideline in the future. Now going back to our normal buildings, our commercial and public buildings, these buildings have been closed for a while, and now we are going back to them. And yeah, it's not proven yet. It was from a few weeks ago. But all the orientation that we are giving here, we are already assuming that the airborne transmission from COVID-19 was possible or is possible. So all the recommendation that we give in the following guidelines already assumed that like 3-4 months ago. Now the specialists that wrote to the World Health Organization were assumed that it was possible. First, let's go through some buildings around the world, and all these documents are on the website of the CDC, so there are articles that are available. The first one is a restaurant in China. So they had a symptomatic or mute symptomatic patient in this table, and they got all people in the other tables, most of the people infected as well. There was a overlapping between the families in these tables. the distance between the gas was lower than 1 meter. They had no air renovation. This building has no windows. So they were just recirculating all the air. And the hypothesis of the transmission was through droplets. Why? Because it was this split unit throwing the air and moving the air around with these droplets. And it was only restricted to this area. If it would be spread to aerosols, so there are smaller particles that can really fly around, it would probably also go to the other patients. So for this specific case, they believe, the investigators believe it was through the droplets. There were no infections in the staff of this restaurant. So the aerosol infection, they were not believing for this specific case. So the conclusion was that the droplets could be carried in the air and they were recirculated in this area. And the recommendation was that, okay, let's increase the distance between people in the restaurants, make a check of the temperature in the entrance. So you can probably, if they have mild fever, so you can identify asymptomatic patients. But the most important thing was increase the renovation. We need to get this air diluted. We need to get fresh air in and contaminated air out. The second building, we are not talking about the air conditioning because it's also at the CDC. It was in Korea. It was in the beginning of the crisis. It was a call center. They had the call center in several floors. And they had only problems in one floor, the 11th floor. And from the 216 employees that work here, 94 were infected. And what they believe is that it was through the close contact, people working together, and no protections, the handshakes, but also the air and the droplets from one to the other, like spreading the virus. Despite the common use of the lobby and the elevators with the rest of the building, they didn't find other contaminated people in this building. So it was really restricted to a long-term contact and close contact, as we can see here in this picture, in this map. Unfortunately, they were not discussing the airborne transmission and how the air conditioning system of this building is. So they restricted the analysis to the possibility of close contact. So, but the air conditioning is not bad. We need air conditioning. We need air conditioning to help us be comfortable, to keep the internal environment safe. And here's a sample that, and this during this crisis, a mall in Malaysia, they turned off the air conditioning when they did the lockdown. And it was almost 2 months without humidity control. And it damaged all the goods that were in the stores and also the furniture of the mall. So everything had this proliferation and growth of mold. So we need air conditioning, and we cannot turn the air conditioning off. So how are we going to deal with the air conditioning now in this pandemic? So there are some international entities working out how to do it, and the first documents were released in the end of March, beginning of April. We have the ASHRAE, we have RIVA, we have ABRAVA, the Brazilian Association, and Eurovent also in Europe. And as we can see, they were all released in a range of almost 2 weeks in between. These guidelines for general air conditioning are not developed for hospitals. They were created thinking about general use buildings. All of the documents say, okay, the critical contamination is droplets and surface contact, but all the documents were, these 3 documents were saying that there was a potential for contamination due to aerosol dispersion. And that's the reason we are looking how to work with the air conditioning in this case. The first action would be increasing the outdoor air, and all the recommendations are to disable the demand controlled ventilation and put it to the maximum that your system can deal with. So increase the external air, increase the renovation of air of the building. Keep the building, the air conditioning, ventilating the building 24/7. Don't turn it off. If you have to, you can reduce the airflow at weekends and at night, but turn it all again on to the maximum airflow 2 hours before the shift and turn it and reduce it only 2 hours after shift. it helps diluting all the contaminants inside of this room. They also were the recommendation was about maintenance was only in the Eurovent is keep the maintenance according to the manual and the project as specified in the project. Humidity, who wrote about humidity was Reva, and keep the humidity at least above 25 to 30%. And Ashray, we know from the papers and from the other guidelines that, yeah, we should keep the humidity in a controlled range between 30 and 60%. The next recommendations are about the filters. So Ashray is telling, okay, increase the filtration if possible to at least MERV 13. And there are some studies that show that from the 13 on, you will see the benefit of doing that. But the filters have to be compatible with your air handling unit and with your device. So in a split system, like I showed in the picture from the hospital, there's no possibility to adding a MERV 13 filter that would be equivalent probably to an F7 from the old European standard. In Europe, they say there's no need to change the external air filters because they already have higher requisites for the filtration. And they usually have at least an F7 filter in the installations, the newer installations. Abrava recommends, okay, try to replace it if you don't need to do a lot in your installation. And changes, it's like to keep the building running. About the toilets, Riva is really clear. There is a possibility of fecal oral transmission due to the aerosols in the bathrooms. So turn on the mechanical extraction in the bathrooms and keep it running all the time. And keep the toilet negative to the room. And also the flush with the closed leads. That's really rotting in the device. And the other association here says also to run it full time. Windows. The Europeans believe that we should be able to open the windows and increase the ventilation as well. Recirculation, try to reduce or eliminate. In Europe, they say don't recirculate air at all. They use a lot of air handling units with heat recovery, so they already are prepared to make these devices working with without recirculation. They can go to this extreme. And in Brazil, also, they recommend to reduce the recirculation of air. There are not practical effects of cleaning the ducts right now. It would not add value to it. And about the air purifiers, Ashray and Reva say, okay, you can use air purifiers with HEPA filters and consider also UVC lighting. But you have to be careful about the equipment that you are selecting. So that's not a really cheap, low-cost air purifier that's sold in a supermarket. So we need to get devices that are with a higher level and where the HEPA filter is really a HEPA filter, where there's no bypass present and so on. There are a lot of considerations to be done. And really important, why are we increasing the air renovation? Because we want to dilute the air. That's one of the tools of contamination control. Dilute the quantity of contaminants. So bring fresh air into the room and reduce the concentration of the contaminants in our building. So how we can do it? We can do it, open the windows, so we bring the air, we will have less return of air. So we will, but the unit will then need to have an increase of the external air. So we need to go to the machine room and see if we can deal with that. The other option is when we have independent fans for the extraction. That's some units are a little bit in the high end. We can just turn our air handling unit to come with 100% external air. And we need to see if we can deal with the thermal loading and so on. There's a lot of analysis to be done, but that's the idea, is to increase. The idea is to increase the amount of fresh air in the building to carry out all these contaminants. It will have energetic costs, but at this time we are paying the bill to keep our tenants safe. So if you look into how the installation is, we need to go back to the project of the building and to the air handling unit, to the as-built, and check what is the impact. So is our unit able to operate with 100% external air? Can we reduce the recirculation? Was the unit designed to open with free cooling? In some regions, we can use the free cooling in a good part of the year. Maybe now is the time to say, okay, we are using the free cooling even now when we don't have all the benefits of the free cooling, and we will have a little increase of the temperature in summer of the building, but we need to do it to get more fresh air into the building. So in this case, we would close the return dampers in these air handling units and try to work with 100% external air. That's the drawing from Brazilian document, and they are discussing. Okay, we have an air handling unit that has one fan that does the supply and extract. That's quite common also here in the US. Try to minimize the return, increase that, open the windows. What will happen with that is we will have more renovation, more external air. We will also move the source of contamination. But all of these documents as well tell that we have to reduce the quantity of people inside of the building. So if you reduce the quantity of persons working inside of the building, we automatically are increasing the fresh air per person. So that helps as well, and it needs to be evaluated. So there is a lot of analysis to be done before we open each building. And in this case, there are several options that we can do. We can open the window. We can check if we can just increase the airflow, and we will move more air in this building. We can reduce the quantity of people inside of it, and we reduce the source of contamination. We can shut off the return dampers and open the windows, and it will be working with 100% of air. But then we need to take a look into how the balance of the air conditioning in all the rooms will work with the supplier, and we need to check if we can deal with the thermal loads and the humidity control. In units with heat recovery, because there is also the risk of a bypass in heat recovery, there are devices that they have no risk at all. One is the turnaround coil that makes the heat recovery with a water system with coils, so there is no risk of cross contamination. So you have your external air coming in, you treat it, and you have to extract air. This system is designed to work with 100% external air. And in the plate heat recovery devices also, we can have a good result without the need of without the risk of a cross contamination. Where it gets a little bit more complex is in the wheel heat recovery device, because sometimes we can have a bypass here, so we need to check it and we need to evaluate it. And Hvac is going to release a document in the next days talking only about that, how to deal with the heat recovery bypass. Then we have other tools that we can do. We can try to destroy the microorganisms. One that we talk a lot is UVC. So UVC is a technology that's really being used in air conditioning for many, many years. And we mainly find them in these devices close to the coils. And the idea is to keep the coils free of the formation of biofilm. Coils of air conditioning, central air handling unit, and even our houses can be pretty nasty and dirty. So with the UVC here, with the correct doses and the continuous exposition, kills all the microorganisms that tend to be attached to the coil and keeps the coil clean. Keeping the coil clean will also allow us to have the nominal flow from our project, because if the coil gets dirty with the biofilm or so on, the flow through it will be reduced because the pressure drop is going higher. So we will lose some capacity of the air handling unit. So definitely I recommend to use the UVC light in the coils. There is a possibility of adding them to the duct, but then there are studies from HEPA and so on. If we want to get the same effect of the filters, we need a lot of UVC emitters in the duct, and that they will have an impact in cost, and it will have also impact on how you are going to install them. And we'll discuss that in the next slide. And there's also the UVC emitters that we can use in the room, and then we will have the air moving through this area. And here we have an area that we have this light of UVC destroying the microorganisms. But that's a long-term action. It doesn't kill all the microorganisms just because it passes in this area. So it needs to pass a few times. For UVC, we have the killing, the survival rate factor, and it's calculated with this formula. There's a deactivation constant, and it varies from organism to organism, so microorganism to microorganism, so we have to check that in labs. We have the intensity, the fluence from the light, and that's data that the manufacturer gives. It's usually in milliwatt per square centimeter. And they also have to inform at which distance from the emitter this value is valid, because as far away we go from the emitter, as the distance goes higher, this intensity reduces. So they need to tell at which distance that is valid. And how long are we going to keep these microorganisms exposed to the UVC light? That's quite important, and we'll see that in this table in a few seconds. So here we have some data for the influenza SARS. Here you can see SARS-CoV-2, I kept the interrogation. There is no lab result test yet. That's what we believe, what some literature shows for it. There's still the need for scientific papers showing it. It was presented in a webinar in ASHI, but there is no, we didn't find the scientific papers attesting, okay, for the SARS-CoV, it's 0.0038. So what happens? Here I'm calculating the survival rate as a function of the exposition time, is the fluence of the light. And here is the calculus of how much we will destroy from it. So to get the effect of a HEPA filter of 99.95%, and it will be a 99.97% tested with 0.3 micrometers, we need at least half second of exposition. So we need to keep the virus half a second exposed to this light with this intensity. So if it would be in a duct with like 6 meters per second, it would be like 3 meters or 10 feet of displacement of the air. So we would need to cover with lightning this 10 feet, these 3 meters, to get the same effect of an HEPA filter. Or we need to increase the power here to reduce the time to get in a shorter range. So there's a lot of calculus that had to be done to apply the UVC lighting in ducts and getting the effect that's desired. So there's not just putting one UVC light in duct and expecting it destroying all the microorganisms. There's a lot of engineering behind it. UVC, also we need to take some care when we apply it. There are studies because UVC light damages materials, it odes materials. And so it can damage filters, rubbers, gasket, plastic surfaces. So if you are using a robot like this one in a room, first, there's not allowed to have a person in this room. It's just a robot doing the work. But it will hold all the material, the painting, the plastics that are inside of it. And in the air handling unit, we need to put it in the spaces where it cannot damage the materials that are suitable to damage. So the ASHRAE has a guideline in the research paper that shows the effect of UVC lights on materials. There's also a risk to people. It can burn the skin and damage the eyes. So UVC lights that are being sold as we can put in our desk, in our room, I would be quite really skeptic of if they work or not. So definitely let apply UVC lights in the coils of the air handling unit. If you are going to put them in the ducts, please be aware that you need to make a calculus of how much you are going to destroy of these microorganisms, and that will be a lot of emitters like you can see in this section. And if you are applying it into the room, please contact a specialist, because you need to keep the lighting in such a way that it's not going to the direction of the occupied zone, because it will be bad for people. And if you need to make maintenance above this point, you need to turn the lights as well off if you are going to work in the ceiling. So there are a lot of restrictions that need to be taken into account, the hazards that come with it. So now we come to the final recommendations. And first, we need to get more fresh air into the building. It's about everything is about air renovation. We need to put the maximum fresh air that we can into our buildings. Don't shut off the buildings at night. Keep the air renovating to reduce the concentration. If you are reducing the flow at night and the weekends, please make it go up again 2 hours before the shift and only reduce it 2 hours after. Make sure that you can open the windows in the building. Allow the tenants to open the windows. It will increase the ventilation and also the confidence of the users. At the moment, we are not looking to save energy. We are looking to get fresh air and to dilute the concentration of the air. At the bathrooms, keep it extracting 24/7. So that's the moment we have to turn off all these movement sensors that we have in our bathrooms. When you go in, turn on the light and so on. Turn it off. Keep the fan extracting full time. Try to adjust whenever it's possible your air handling unit to work with 100% external air. I know that's hard in some buildings, but we should sit and evaluate this possibility, even if we lose a little bit of the temperature control. We need to find other ways of doing it. Inspect the bypass and leakages in the heat recovery system. If you have split systems and fan coil units that don't have fresh air, just keep them circulating and open the windows. It's like there's no point anymore to try to keep temperature control at the cost of increasing the concentration of contaminated particles inside of the room. There's no need to clean the ducts right now. If the installation is running, let the installation run. Don't turn it off. Keep it running. Change the filters as planned by the maintenance procedures and pressure drops. If you can, and the installation allows, increase the efficiency of this filter, at least to a MERV13 or a F7. That would be a PM 2.5 in Europe. Use the protective equipment to replace the filters. Don't go replacing filters without a mask and gloves and at least the glasses, and put them inside a bag. Don't walk with these contaminated filters around. And now here I kindly would, I'm grateful to Professor Stephanie Taylor, because she shared that picture and allowed me to use it in my presentations. Like the buildings in the past were designed to be a protective storage, to put us inside of the building, keep us safe and protected. Then we came to a point where, okay, now we need to save energy inside of this building. So there are a lot of actions from the 70s to the 90s, reducing the amount of external air. And then we come to the sick building syndrome. Then we began to increase the airflow, the external renovation air again. But we need to look in the future. We need to compromise. It's not all about energy. We need also to keep our building safe for the health of the tenants. That means who is inside of the building needs to have a good environment. And that would be the biggest challenger for the design in the next years, is how are we going to guarantee that we have a safe environment, that we are diluting the contaminants, we are keeping the humidity under control, and then we work with protection, energy, and health all together, and not just selecting one of them. So it will have some impacts probably in budgeting, and that will be the big challenge for all the HVAC engineers doing design, and for the companies that develop the components for these buildings. So here I let my contacts for everyone that has questions. I like to share information and to discuss. And I believe that I learn a lot from these discussions. And everyone, we learn more when we are talking to each other than we are just reading and trying to study by ourselves. So anyone that wants to contact me, here my corporate emails, please contact me, and it will be a pleasure to talk to you and to see how we can help. And we are here to help to find solutions. Thank you very much.